All right, so this is our screencast on law of sines and law of cosines. You learned the law of sines and law of cosines in geometry or geometry honors, and we are going to do a quick refresh of both laws and then different situations. Now, when I say different situations, I mean given different pieces of the triangle. So let's go ahead and look at that. So we use the law of sines or law of cosines when we have a triangle that is not a right triangle, okay? Law of sines and law of cosines work for all triangles, but why would we not want to use SOHCAHTOA on right triangles? It's easier, right? It's less work, I should say. So when we have a non-right triangle, which is called an oblique triangle, we use the law of sines or law of cosines. So we're first going to talk about the law of sines, okay? So we use the law of sines when you are given angle, side, angle, 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 side, or side, side, angle, okay? So let's first talk about how to draw the triangle. So you're gonna be given a triangle. If our triangle was called triangle ABC, you would make a triangle, label each vertex A, B, and C respectively. It doesn't matter which one which though, so I don't need to say respectively, just any vertex A, any vertex B, any vertex C. But then the sides are important. So if this is angle A, the side opposite of that is side A. Angle B, the side opposite of that is angle B. Side C, sorry, angle C, the side opposite of that is angle, side C. I swear I can talk, okay? So that's how we're gonna label. So if you were given, let's say, this angle, this side, and this angle, that's angle, side, angle. We would use the law of sines. If you were given this angle, and this angle, and this side, or this angle, and this side, that's angle, angle, side, and you use the law of sines. Lastly, if you were given two sides and the angle not in between, so not that one, side, side, and an angle outside, you'd use the law of sines. Now, SSA is called the ambiguous case. Ambiguous case. We do not talk much about the ambiguous case in this class due to the fact that we haven't learned, you guys haven't learned the unit circle yet. You haven't learned what trig functions look like what the sine graph looks like, what the cosine function looks like. You haven't learned any of this. So there are things that are true about a triangle that has SSA, and it's the ambiguous case means that different things can happen, but the explanation behind it comes with that trig that you learn in the future. So though we're going to see a situation that's SSA, I'm not going to even bring up the ambiguous case. Okay, great. I'm glad that's covered. All right, so what the law of sines says is that this is how you use it. So what you're gonna do is you're gonna take any angle that you were given. So let's say you were given angle A, you're gonna take the sine of that angle and you're gonna put it over its opposite side that you were given. So those two things you're given an angle and its opposite side, and you can set that equal to the sine of another angle that you were given over its opposite side. That might be your side that's missing. So one thing's gonna be missing. Either this is gonna be missing, or this is gonna be missing, or this is gonna be missing, or this is gonna be missing. Everything else you'll know, okay? It doesn't have to be angle A and side A or angle B and side B. It could also be angle C and side C. So it's any two of these. So you're either setting this equal to this, or the last two equal to each other. It's not three ratios set equal to each other. It's just two making a proportion. Okay, that was enough explanation on that. So this law is powerful because it allows us to use the sine function to solve for measures of angles and lengths in non-right triangles, also referred to as oblique triangles. All right, so let's jump in here. Given triangle ABC. So first off, what I'm gonna do is I'm gonna draw a sketch of this because there's no way on earth I'm gonna know what to do without drawing it. So given triangle ABC, angle A is 53 degrees. Side A is 18, so you're gonna go opposite of angle A and label that side 18. Angle B is 39 degrees. And then it says solve for B and C. So one at a time, right? Okay, so first off, we have to decide which law we're using. So if you look here, you are given angle, angle, and then this side is not in between them, okay? If it was angle, angle, the side in between, that's angle, side, angle, but this is angle, angle, side. So So we have angle, angle, side, which tells us to use the law of sines. And I just realized that we haven't even talked about law of cosines yet. So obviously it's law of sines, but still when they're mixed up, it's important to know. Okay, so law of sines is a proportion. Okay, law of sines is a proportion. All right, so first thing I'm going to do after I do that, I don't have to do that first, is I'm going to find the missing angle in the triangle if I can, because I might need it. And guess what? I can. So I'm doing 39 plus 53, which is 92, and then 180 minus that, which is 88. I don't know why I said 38, 88 degrees. Okay, so 39, 53, 88. All right, so now I'm going to use the law of sines. So the first ratio that I always do is the ratio of an angle and its opposite side that I do know. So this is that ratio that I do know. So sine of 53 degrees over 18. And then now I need to see what I'm looking for. I'm looking for side B and side C, so it doesn't matter which one we do first. I'll do B first. So that's going to be sine of 39 over side B. And now, easy peasy from here, it's just cross multiplication because this is a proportion. So we're going to multiply B times the sine of 53 degrees is equal to 18 times the sine of 39 degrees. All right, get B by itself. This is multiplication right here, so I'm going to divide by sine of 53 degrees. And then I'll show you how to type this in your calculator just in case me just saying out loud what I'm doing while I'm doing it on my calculator, and you don't see it, cannot be very helpful. All right, so first off, this is degrees here that I'm typing in my calculator. So I want to make sure my calculator's in degree mode, which mine is not because it restarted. So we go to degree mode, hit enter. Okay, and now I'm going to type this. So 18 sine of 39, close the parentheses on the 39, divided by sine of 53. Close parentheses, hit enter. And we're rounding all of our answers to nearest thousandths. We're doing 3 decimal places for everything. All right, so that is 14.184, and that's the length of side B. All right, now we're going to find side C. So once again, we're going to start with that ratio that we do know. We're using the law of sines again. So sine of 53 degrees over 18. Notice I don't even need my triangle because I'm looking right here. But now for side C, I need this angle and this side. So sine of 88 over C. Cross multiply, we get C times the sine of 53 is equal to 18 times the sine of 88 degrees. Divide by the sine of 53 degrees. And C is equal to, I almost typed it in my calculator off to the side. Notice everything's the same except for that 39 turns to an 88. So it would be probably faster just to retype it, but I'll type over it and hopefully it won't make a mistake. And I get 22.525. Okay. All right, I thought of something I was going to say, but I can't remember it, so I'm just going to move on. Cool. All right, here's the next one, okay? Once again, we have triangle ABC. Oh, I remember what I was going to say. You must show your proportion, so this. You must show what you're typing in your calculator. So if you're like cross multiplying in your head and you get B equals this, that's fine, but I need to see this because that's what you're typing in your calculator. I can't mind read what you're typing in your calculator. There we go, I remember what to say. All right, triangle ABC again. Angle B is 37 degrees. Side B is 10. Side A is 16. All right, let's look to see what we have here. So we have side, side, and then this angle is outside. It's not in between. This is in between, right? So it's side, side angle. This is the ambiguous case. What happened to my 6 on my 16? This is the ambiguous case, so I will kind of mention why it's the ambiguous case, but, okay. So let's go ahead and set up the law of sines and do this, okay? And law of sines, proportion. All right, if you can find the third angle, you find it right now, but for side angle, you can't because there's 2 angles missing. So we're gonna do the sine of 37 degrees over 10. That's the ratio that we do know. And then we're looking for angle B. What? That's a typo. Angle B is 37, I'm done. So I'll fix that. Let's do angle A, all right? We don't wanna do angle C, we can't find angle C right now. All right, we'll do angle A, sine of angle A, over 16. I'll have yours fixed in your notes because angle B is 37, done, right? All right, let's cross multiply and see what we get. Okay, so we have 10 times the sine of angle A is equal to 16 times the sine of 37 degrees. We need to get angle A by itself. So right now it's trapped on this sine of A, but this 10's hanging out in front of that multiplier, so I'm gonna divide by 10 first. All right, make that a little bit bigger. 10, okay, these cancel. Now I have sine of A, I'm just moving this over so I don't have to write it again. I have sine of A is equal to that, and I need to get rid of sine. So to get rid of sine, I use its inverse, which is sine inverse. So this is what I'm putting in my calculator. I really hope I get an answer. Part of the ambiguous case can be it's not a triangle. Like it would be that this angle wouldn't, this is too short to be a side. So I'm hoping, because I made this one up on the fly, I thought I checked it, but obviously there's a typo in it. Sine inverse of 16, sine of 37, close the parentheses, divided by 10. Come on, give me an answer, thank goodness. Okay, so angle A is 74.345 degrees. Okay. All right, so we got an answer here. Sometimes you'll get an error because that piece is too short to make a triangle, and it would say error, no triangle, I think it says, and then there's no triangles. But then also there can be 2 triangles, okay? The supplement to this angle could also work if it still makes a triangle. If you think about what the supplement to this is, it's 105 point something, something, something. And you'd have to ask yourself, can this angle be 105 point something, something and still make a triangle? And the answer is yes. So this is not the best example on the face of the earth because there's actually a second answer for angle A, but you don't know that yet and you don't know why yet, so we're not gonna even talk about it. I just wanted to practice solving for the angle, and now you won't see that again until pre-calculus. Okay, that was long-winded. Let's move on to the law of cosines, okay? We are gonna write 3 equations for the law of cosines, but all these equations are the same, okay? So law of cosines is used for SSS or SAS. So this is really what I have memorized, is that if it's SSS or SAS, it's law of cosine. If it's anything else, it's law of sines, okay? So here's how the law of cosines work. So what you're gonna do is you're gonna start with any side squared. So that's A squared. And that's gonna be equal to the other 2 sides squared added up. B squared plus C squared minus 2 times those 2 sides that you just wrote down multiplied times the cosine of the angle opposite of the side you started with, A. So this equation right here is used to solve for side A or angle A. If you're solving for side A or angle A, this is the equation you would write. Now let's write the equation if we were solving for side B or angle B. Well, then you would start with B squared is equal to the other 2 sides squared added up minus 2 times those 2 sides multiplied times the cosine of the angle opposite of the side you started with, B. Pause the video and try this for side C and angle C. C squared equals A squared plus B squared minus 2 times A times B times the cosine of angle C, okay? Now, if the angles were RST, it would be the same thing, right? It's just, they're all the same equation. It's just so I can refer to what I'm looking for. All right, so this is nice because these are already drawn for you. Wonderful. Look to see what you have. You have side, side, side. So you are using the law of cosines. We need to find angle A. So if you want to put an angle A here, you can, okay? So now if you're solving for angle A, you're starting with side A squared. So we're going to do 6 squared is equal to the other 2 sides squared added up, 5 squared plus 7 squared, minus 2 times those 2 sides multiplied, times the cosine of angle A. All right, now I need to solve for angle A. So what I do here is I do what's called buckets on this. So you're gonna break this into 3 buckets, this bucket, and this bucket. And I want those all to be one number instead of all these numbers here, right? I got a bunch of numbers written down. So I wanna know what 6 squared is, which is 36. I wanna know what 5 squared plus 7 squared is. That's 29 plus 49. And you can use your calculator, which is 74, right? 25, 49, yes. Minus, I want to know what 2 times 5 times 7 is, which is 70 cosine of angle A, okay? So now imagine instead of cosine of angle A here, you had 36 equals 74 minus 70x, right? If I said what's my next step to getting x by itself, no one would say do 74 minus 70. So please don't say that on the equation that we have. You know you have to subtract 74 from both sides next, okay? And that's what we're going to do. We're going to subtract 74 from both sides. So just so I don't make a mental math error, I know it's negative 38, but my brain is telling me to check, okay? I have to. I know I'll make a mistake. I probably made a mistake up there and I won't even catch it. Minus 70 over cosine of angle A. I need to get cosine of angle A by itself, so I'm going to divide both sides by negative 70. So now I have cosine of angle A is equal to negative 38 over negative 70. You can get rid of the double negative if you want. You don't need both, right? You don't need either if it's both. But now I need to get rid of cosine, right? The only thing that's going to cancel out cosine is cosine inverse, not division, right? No, oh, divide by cosine. No, we can't, what, right? Cosine inverse is what undoes cosine. So now we have A equals cosine inverse of negative 38 divided by 70. I'm just going to write 38 divided by 70 because you don't need the double negative. 57.122 degrees. One thing that I know about this is that my answer couldn't be obtuse. So if I would have gotten an obtuse answer, how would I get an obtuse? Let's say I did cosine inverse of negative 38 divided by, and I forgot the negative on my 70, like I got 122.878, right? I know that's not right. How do I know that's not right? Because 7 is my biggest side, so C has to be my biggest angle. There can only ever be one obtuse angle in a triangle. So like, you can sometimes catch mistakes if you're making them. Okay, great. Let's move on to the next one, and then I'm gonna have you pause the video and try the rest of them on your own. And then you can check the answer with the answer key in Schoology. All right, so for this one right here, first we have to know what we have. So we have side angle side. So we are using the law of cosines. The law of cosines always starts with the side squared. And I forgot to mention, where's my variable, right? Because I need to know where my variable is. I'm looking for side C. So if I'm looking for side C, I'm starting with C squared, right? Equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 49 degrees. This equation is so much easier to solve, right? If you look where C is, it's on this side of the equation, it's almost by itself. The only thing I have to do is square root to get it by itself. You don't have to do square root plus or minus because the side length has to be positive. So we're typing in our calculator, square root of 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 49 degrees. Enter. 9.057. That's the length of side C. So I always say to myself, if it's SAS, it's the easiest problems, right? It's the least amount of work. I hope for SAS problems. All right, if you pause the video, you have 2 to try here. And then once again, you can check the answer key with my answer key in Schoology.